So this is going to be another one of these examples of the limiting reactant. And you can tell this says that the student has 1.0 grams of silver nitrate, and you can write it underneath just like this. And then you'll notice it also says 1 gram of magnesium chloride, so again we're writing it underneath. You can see that both of these, it says that they're the same amount, but you can tell this is that kind of a problem because we have a certain amount of each reactant. So I'm going to do the silver nitrate in blue. So we're going to do 1.00 grams of the silver nitrate. I scooch it, it's a little funny. So we're going to set up our train track. Remember, you need 2 sets of train tracks. So I'm going to go ahead and write down to remind myself so I don't have to think about next. So I'm writing down 1.00 grams of magnesium chloride. There we go. So I'm going to need to turn my grams of silver nitrate into moles of silver nitrate. So moles of silver nitrate. Now this is the point that I'm switching to something else, is when I'm in moles on the bottom, I'm going to switch to moles of, if you look, the problem is asking for silver chloride. It's part B. So you might have to look ahead on some of these to figure out what you're trying to turn it into to save yourself time. It'll turn into one of the 2 products, but you want the useful product. And we're going to go from moles of silver chloride into grams of silver chloride. Now we're going to fill in the molar mass. It was in the problem, but you would just add up to get that number. We're going to look at, right there, you're going to see the ratio of those 2, silver nitrate and silver chloride, 2 to 2, or you could write 1 to 1 is fine. You cancel them out however you want to think of it. And then the silver chloride amount is, it's in part B. Do you see it? So 143.32 grams in 1 mole. And then we got the magnesium chloride. It's going to have the same kind of look to it. So grams on the bottom, magnesium chloride. May it turn into moles of magnesium chloride. And then throw that down to the bottom, the moles of magnesium chloride going into moles of silver chloride. You can see this is again where we can convert between. And then we're going to put in moles of silver chloride on the bottom and grams of silver chloride on the top. There we go. And that number comes straight out of the problem. You notice the tail end of both of these are going to look the same because in both cases you're turning them into the same. So we're just grabbing those numbers. You can see our molar ratio is 1 to 2 this time. We got right in the magnesium chloride's molar mass. And we're going to put these numbers into the calculator. So I'm going to need 3 sig figs because of the 1.00 grams. So I get 0.844 grams of silver chloride. Notice I've got 3 sig figs over here for the magnesium chloride. This is 3.01 grams of silver chloride. You should see both of them. Them's going to be way smaller. We're crossing out the big one. We're keeping the smaller one. And across from the big one, we're writing who was the excess. And above that, the limiting. The limiting is what gives us the real amount, the 0.844. So that I'm crossing out the one because I just am remind myself, don't start with that one for part C. When I'm trying to figure out how much left over. Also, I was a little off here. Yeah, it should be 0.844 grams. All right, so part C. So part C, we're starting with the grams of the silver nitrate because that's the one that's limiting, and it's going to use up a certain amount of my magnesium chloride. Oh yeah, by the way, that was grams of silver chloride and grams of silver chloride. If you like writing it that way, it might be helpful. How much is produced? And this one is a reactant. We're trying to figure out how much reactant we used up. And it was the silver nitrate that used it up. So we're going to go from grams of silver nitrate into moles of silver nitrate. I'm going to go from moles of silver nitrate into moles of magnesium chloride. And then we're going to go from moles of magnesium chloride to grams of magnesium chloride. So molar mass in 1 mole. Look at the reaction. So we're trying to go from magnesium chloride into silver nitrate. I'm sorry, silver nitrate and magnesium chloride. So 2 to 1. Make sure you get the numbers lined up right, and then we're going to do our molar mass, which was in the problem. We're figuring out how much was used, but the problem is actually asking how much was left over. So I need 3 sig figs. 0.280 grams is how much was used. It's always good to write down used and who you're talking about, because it's wanting to know how much was left over. So I have to go back. That original amount, I've got 1.00 grams of magnesium chloride. So 1.00 minus the 0.280 is going to give me 0.72. I only need it to go to the 100ths place. You see there, that one's the shortest position. This is subtraction, so the shortest place position is the hundredths. And that's for magnesium chloride. And that's how much was left over. Now on this problem, we've got this reaction right here. Notice it's not balanced, which is a bummer. You got to also balance something and do this whole problem. So we got 4 to 3 and to 1. That was an easy balance, wasn't it? We're putting in the amounts. So notice we've got grams of aluminum and we got grams of carbon. We have a gram amount for each reactant. That means it's a limiting reagent. If we had been given a product amount over here, so like let's just say we had some number for that, that doesn't mean limiting reactant problem. You don't need all the train tracks for that. What that's for is to calculate the percent yield. If you're ever given that number, it's the number of, it's like what the person weighed after they did the actual experiment. And that's what that number is for if you ever get it. Notice this problem though, this one's giving you an amount for each of the reactants, not the product. Okay, so we're going to start with 2.50 grams, and I'm just doing aluminum falls first. I'm going to write out the amount for the carbon. No, I need 2 train tracks. What am I turning into? It's saying, you know, it only turns into one thing, the aluminum carbide. So that's what we're trying to figure out, grams of that guy. And for this one, we're turning them both into the same thing. Doing grams of aluminum into moles of aluminum, and then we're going to throw that aluminum down on the bottom, moles of aluminum. We're going to turn it into moles of the silver carbide. I'm sorry, aluminum carbide. Then we're going to go again throw the moles on the bottom into grams. .5 grams of carbon, go from carbon grams to moles of carbon, and then we're going to go moles of carbon into moles of aluminum carbide, and then for moles of aluminum carbide into grams of aluminum carbide. So we're just filling in the numbers using that molar mass. It's in the problem, or you could get it off the chart. This is from the reaction. Look at the coefficients. So it's 4 to 1. Make sure you get them in the right spots. Hate to get it wrong if you put them in the wrong spots. And then molar mass, 1 to 143.96. Now we're going to use the molar mass here, again from the periodic chart, or it's in the problem. Then now we're going to use our moles of carbon coefficients to our carbide, so it's 3 to 1. And then we're going to use our molar mass, 143.96, yep. We're going to solve both of these. They both are going to go to 3 sig figs. So we've got 3.33 grams of aluminum carbide. 9.99 grams of aluminum carbide. And then we're going to cross out that amount because that's the larger one and it's not possible. We're going to go back and write excess beside the one that did the larger amount, and we're going to go and we're going to use limiting up with the top one. So the 2.50 grams of aluminum is the limiting reactant.